that I have, and then from like homework that I didn't really know how to do.
Okay.
The first one is like dealing with imaginary numbers.
Okay.
So, are you ready?
Uh-huh.
Okay. In parentheses, 3 plus 4i plus 7 minus 2i. And then it says to simplify each expression.
Yeah. Adding, subtracting, and multiplying are all very straightforward. You add the real parts, you add the imaginary parts. So that's going to be 10 plus 2i.
Oh, okay.
Okay? And the only thing that is difficult is division. But let's do some of these just to make sure you know how to do them.
Okay.
What's another one?
I have 3 plus 5i in parentheses squared.
Squared means what?
Times itself.
Foil those two.
So that'd be 9 plus 15i plus 15i plus 25i squared.
Simplify.
9 plus 30i
I squared is what?
equals.
If I equals the square root of -1, then I squared equals what?
-1.
Always make that.
Okay. Oh, so then you just put it in parentheses?
Oh, I'm sorry, what?
Never mind. Go ahead.
Yeah, always make that conversion. In other words, you can't do anything with I. That's simplified. But anytime you have an I squared, that can be simplified. So I have 25 times -1, which is the same as -25. Combine the real part of this expression and the imaginary part, and you got -16 plus 30i.
Okay.
Okay?
That makes sense.
Okay.
The next one is in parentheses 3i and then in parentheses 2i squared.
Like that?
No, the squared on the 2i is like outside of the parentheses.
Like that.
Yeah.
Okay. Which operation do we do first?
Square?
Yeah, in other words, refer back to PEMDAS. Remember PEMDAS?
Yeah, is then, so parentheses first?
Well, parentheses or exponentials. When you have both parentheses and exponentials, you tend to do the exponential. That's what gets rid of both. In other words, as
Okay.
I square this, I'm going to lose the parentheses also. So I'll keep that parentheses for the moment. What do I get when I square this?
4i squared.
Yeah, and now I don't really need parentheses. And what can I substitute for I squared?
-1.
Times a -4, which is -12i.
Okay. That makes sense. This next one just says I cubed.
Let's talk about each of these, because this is going to come up also. I squared is equal to what?
-1.
I cubed is equal to what? It's equal to I squared times I, right?
So 1.
Negative I. I cubed is the same as negative I. And I to the fourth,
I don't know.
I squared times I squared,
Uh,
1.
I
Negative,
1.
negative 1 times
Oh,
negative
okay.
1 is
Yeah.
positive 1. Okay? Now I go through each of these 4 because there's a sequence here. I to the fifth equals I. I to the sixth equals negative 1 again. I to the seventh equals negative I. And I to the eighth equals 1. In other words, every multiple of 4 repeats itself. And you will get questions like, what is I to the 502nd power? What is it?
1.
No. First of all, separate that into an even multiple of 4. So it becomes I to the 500th, which is an even multiple of 4, times I squared. Any even multiple of 4 is equal to 1. So this becomes 1I squared. I squared is negative 1, so it becomes negative 1. In other words, this is the same as I squared. Once you take away all multiples of 4, if I said I to the 49th, well, 48 of those can be taken away because 48 is a multiple of 4. So that's got to be the same as I to the 1, or just I. Have you had this yet, where they've given you big numbers on I?
Not big numbers,
Or
no.
you haven't seen this sequence over here?
Well, okay, I guess they have, because I have 32 right here.
Okay.
So
You have
that's not that
32?
Yeah,
Okay.
but it's the same.
Yeah, okay. Well, first of all, let's look at I cubed. I cubed is what again?
I cubed is negative 1. Or, I mean, I.
Negative I. I know it's confusing because it's hard to recognize the ones from the I's over here. But, okay, what's the next one?
It was, I to the 32.
Okay, what is that going to be?
So 32 goes into 4, so isn't that going to be 1?
4 goes into 32, yes. Exactly, even with no remainder, which means it's this one here. Okay, so you're right, so it's 1. Whatever, take the exponent, divide it by 4, and whatever your remainder is, that's which number it is. In other words, if it was 34, I would divide 4 into 34. I would get 8 with 2 remainder, so it's I squared. And if there's no remainder, it's that one.
Okay.
That's the most.
So then there's always going to be a remainder of 3 or 1, or 1, 2, or 3 then?
Yeah. Yeah, and no matter what number you want to pick, 99. In other words, because we're dividing by 4, the remainder can only be 0, 1, 2, or 3.
Yeah, okay.
Okay. Now, I mentioned that addition, let's just do a subtraction one. 3 plus 2i minus 5 minus 4i. Simplify that.
Would that be -2 minus 6i
Not minus.
plus 6i.
Right, because this minus right there has to be distributed to both terms.
Oh,
So
okay.
it actually becomes a minus, which becomes a plus. So you have 2i plus 4i plus 6i. All complex numbers are written, if you can, like this format. A plus bi, where that's the real part, that's the imaginary part, that's the real coefficient of the imaginary part.
Okay.
Now, when we first started talking about this, I said the only one that's difficult is when you have division. Division by complex numbers is a little bit like division by fraction. It's not really division. When you divide a fraction by a fraction, you invert that and multiply, right? So it always becomes a multiplication problem, not a division problem. Well, similar with complex numbers. I don't actually divide this into that. What I try to do is convert the bottom to a real number. Well, anytime you have a complex number and you're going to try to convert it to a real number, if we multiply by the conjugate, that's the conjugate. It's always the same two numbers with the opposite sign in the middle.
Okay.
If you multiply a complex number by its conjugate, it turns real. Notice what we get here. We get 4 minus 6i plus 6i minus 9i squared. Well, these two terms always cancel because we're multiplying by the conjugate. This always converts to a real number because I squared is minus 1. So this becomes 4 plus 9, 13.
Okay.
So the denominator is made real. Now, I can't multiply the denominator by that unless I multiply the numerator by it also, because I can only multiply fractions by the number 1 without changing their value. So now what happens is the numerator retains an imaginary number in it, but that's okay. You can have imaginary numbers in the numerator. You just aren't supposed to have them in the denominator. Okay.
Okay.
So this numerator becomes 6 plus, or 6, excuse me, 6 minus 9i minus 2i plus 3i squared, which simplifies to, that becomes a negative 3, so I end up with 3 minus 11i. So that is my new numerator. Sorry for running out of room here. I should learn to start my writing always on the far left. I don't know when I'm going to learn that. But so, didn't help any. That is my answer to this division problem. And I never did any divisions. All I did was multiplication, the whole thing. Okay? So,
Okay.
but that's how you handle it. Now, there's one special situation where if you had something like this, that's still not a division problem. It's still a multiplication problem. What do I have to multiply the bottom by to turn it real?
2i. Or wait, negative 2i.
You know what? Either one works in this case, but just sticking with this idea of using the conjugate Well, the conjugate of that is negative 2i.
Okay.
In this particular situation, multiplying it by 2i would also turn it real. It would turn it into negative 2. This is going to turn it into a positive 2. That's the only difference. But in keeping with multiplying by the conjugate of 2i is negative 2i. Okay, so I have to multiply the top by negative 2i, and then I just multiply that by each of those terms. Simplify, the bottom is now 2. Okay, so in a nutshell, we have covered imaginary numbers almost completely, and that's almost all there is to it at this level. Let's make sure you know how to do this. Let me think here for a moment. What's that equal to?
I actually had this on my team test the other day. I don't know how to do this one.
Okay. The very first step is always take out the negative 1. In other words, when I say the square root of AB, that's always the square root of A times the square root of B. Okay? That's an important principle.
Okay.
So the first thing I want to do is take out the negative 1. Well, what's that leave? Square root of 8. And I know what that is.
Oh, that's
I. What's square root of 8 simplified to?
2.82.
No, don't do it to a decimal. Leave it as a fraction, radical. In other words, here's how you do these. You find a factor of this number that is a perfect square. Well, 4 is a perfect square. And now I can make that into a non-radical number. So there's your answer. Okay. So the answer to this question then would be, actually, it's generally written 2 root 2 I, like that.
Okay.
But you will never get confused if your first step is always to factor out the square root of negative 1. I mean, you could give the wrong answer here. You might say square root of 8i, and be careful how you write it when you do that. You don't want to put the I under the radical sign. It's just we generally put the real number in front of the I. You would lose points if you put that down, because you hadn't reduced the square root of 8 to 2 root 2. But you probably wouldn't lose full credit. You'd get partial credit. The key, the only thing that confuses most people, in other words, as long as you know how to reduce something like that, then adding a negative sign does not make it more complicated. Just factor out the negative 1 and replace it with I, and it's the same problem as that, basically.
Okay.
What else you got? We got about 10 minutes.
I have like solving an inequality.
Okay.
Okay, so it's 3, and then absolute value of x plus 2 minus 3, which is greater than or equal to negative 3.
Okay.
Oh, wait, it has a line under it. I'm sorry.
Like that?
Yes.
Okay. First thing we need to know is, what does this mean? Hold on.
Doesn't
Not done. Yeah.
Okay.
What does that mean there?
It means that...
It means two different things. What are they?
So x plus 1 is greater than 2,
or
x minus
no,
1?
never change the inside. Never change what's inside the absolute value. Only change for the second part, change the direction of the inequality and the sign on the number. You with me?
Yeah.
Okay, and that, as long as you do those two things, and the reason I write it horizontally is because then we have to solve each inequality vertically. In other words, I now go down and solve this, so x is greater than 1, or x is less than minus 3. So you want to make your two statements go horizontal, because then you can solve each one vertically. Okay? So let's go back and look at this problem and do exactly that. First of all, we want to simplify it if we can. You sure this is, did I write it correctly? Is this the way it's in your book?
Yeah,
Okay.
it is.
What's the first step? This would not be a good problem. Let's do this problem, and then I'll tell you why it's not a good problem. It does not illustrate what you need to do. What would the first step here be?
Well, I feel like you would divide by 3.
No, that'd be the second step. The first step is to get rid of that. So we can add 3 to both sides. Okay. Which turns this negative 3 into 0. So now we have this. Now the second step would be to divide by 3, which leaves that 0. And now what's the third step, or the fourth step?
To write your x.
Go ahead.
x2, and then x.
Is what? Give me all of it.
X plus 2 is greater than or equal to 0, and then x plus 2 is less than or equal to negative 0.
Well, that's why it's not a good problem.
Okay.
Because negative 0 and positive 0 are the same thing. So it doesn't illustrate the fact that you not only have to turn that around, you have to change the sign on that number. Okay, it doesn't mean we can't solve it. Let's go ahead and solve it. So the left one, what's the answer?
Negative 2. Or x is less than.
Greater than or equal?
Or no, because that's greater than or equal to negative 2.
Or?
And x is less than or equal to negative 2.
Okay. Well, that's a strange solution set. X is either greater than or equal to negative 2 or less than or equal to negative 2. That means any number we pick for x satisfies that inequality. I can pick negative 1,000,000. I can pick positive 1,000,000. It doesn't matter. The whole thing about the absolute value signs means that it's always positive or 0. So this is almost by definition. We didn't really need to solve it. But let's go back here and change this problem just slightly, if you don't mind. It'll be a better illustration.
Okay.
I'm going to change that to 2. Negative 2. So at the end of my first step, at the end of my second step, and now what two things can I write?
You can write that x plus 2 is greater than or equal to I divided by 3.
1/3, yeah. That's 1 divided by 3. Or x plus 2
is less than or equal to negative 1/3.
Yeah, see the difference between having a 0
Yes.
here and not? In other words, at least with this problem, you learn that you have to reverse that and you have to change the sign on that. When they give you one that has 0, you don't learn that. So, anyway, go ahead. What else you got? You got time for maybe one?
Okay. I have one that says simplify,
Okay.
and then it's in parentheses 3x cubed, and then that to the negative second, and then x to the fourth.
Okay.
And then that is all over 6x to the negative first,
Okay.
times y in parentheses to the negative third.
And they say, give your answer all positive exponents, right? Okay.
It doesn't
What
say that in the
what is this equal to?
x, negative x to the negative 1,
No? X squared,
or x
x
over
squared times
x
x
over
to the
x to the,
third, you add the exponents. In other words, when you're multiplying same base, different exponents, you add the exponents. When you are dividing same base, different exponents, what do you think you do with the exponents?
subtract them.
Uh-huh. And the only other thing you can do is what I call double exponentiation, which is x squared. If I take that whole thing to the third, what is that?
X to the 6th.
Yeah, those are the only 3 rules you need. Okay? Multiplying, you add. Dividing, you subtract. When you're exponentiating, you multiply. Always one level less. So let's simplify this part real quick.
So that'd be negative 9x to the negative 6th.
No, remember, negative exponents do not mean negative numbers. Okay? First of all, it's just reciprocal, but this negative 2 has to apply to that 3, so I'm going to write it for the moment like that. And then what's x cubed to the negative 2? Because that negative 2 also applies to the x cubed.
6.
Negative 6. Right? Negative 2 times 3?
Yeah.
Okay. And then times x to the 4th. Okay. Now simplify that.
So negative 9x to the second.
Hold on. The only parts we can combine are those parts because they're same base. So up top, I'm going to add these exponents. I get x to the minus 2. This 3 to the minus 2 is the same as having it in the denominator to a positive 2. Okay? You with me?
Okay.
So we've simplified the top. Okay? So here's where we're at. 3 squared is 9. And now we have the bottom to deal with. 9 times 6 times x to the minus 1 times y to the negative third. Now, when you have a negative exponent, you can just move that to the other side of the fraction bar and turn it positive. So if I have a y to the negative third in the denominator, I can make that y to the positive third in the numerator. Just like if I have an x to the minus 2 in the numerator, I can make it x to the positive 2 in the denominator.
Okay.
Okay? But before we even get to that, let's go ahead and do, what are we supposed to do there? We're dividing same base.
Then you're going to subtract.
Okay, minus 2 minus a minus 1 is minus 1. So this becomes x to the minus 1, but let's put it in the denominator as x to the positive 1. We still have this 9 and that's 6, which is 54. We've gotten rid of that term and that term. And
So
the only
then,
thing left is y to the minus third. If we want positive exponents, we're going to put it right there.
okay.
That is your answer.
Okay.
And it's real simple. It's just a combination of those three rules. If you remember those three rules, remember you have to have the same base. In other words, if I'm doing this, 2 cubed times 2 to the 4th, I can say that that's 2 to the 7th. But if I'm doing 2 cubed times 3 to the 4th, not the same base, I cannot do anything with it.
Okay.
Okay? All right. Colin, you good to go?
Yeah, definitely.
Okay. Have a good one.
You too. Thank you.